就我的了。哎呀，太高了，拿起几本书。老师镜头。
Doctor, do you have any connectivity issue? Please let me know if you have any connectivity issue so that I'll be able to play the video which you have sent yesterday.
可以说吗？哎，可以了这边。Good morning, ladies and gentlemen. This is Jianping Yu from the School of Foreign Studies and the Institute of Computational Linguistics of Yanshan University, China. The topic I'm going to speak today is APOSD-based word sensitive disambiguation, feature selection, and knowledge discovery of English modal verbs and preposition. Why is APOSD? APOSD represents attribute partial order structure diagram. Our team of computational linguistics at Yanshan University started the research on word sensitive disambiguation since 2006. We have used different approaches such as BP neural network, support vector machine, naive Bayesian model, fuzzy Siemens clustering, adaptive network-based fuzzy inference systems, and attribute partial order structure diagram. Some comparisons have been made to the performance of these approaches. As a result, the APOSD showed a prominent performance in accuracy of word sense disambiguation and knowledge discovery. This is the result of a comparison of accuracies of word sense disambiguation of 4 English modal verbs by different approaches. As you can see from the result that APOSD make an improvement in accuracy of word sense disambiguation. What we have done by APOSD? We have done word sense disambiguation of English modal verb and prepositions. We have also done feature selection for word sense disambiguation. And then we have investigated the features causing semantic merger of English modal verb. The significance of our research. English modal verbs and prepositions are considered semantically complex words. Modal verbs have indeterminacy of semantic gradients, semantic merger, and semantic ambiguity. And the prepositions have semantic ambiguity. These indeterminacies bring troubles to the word sense recognition by machine and to machine translation. Therefore, the word sense disambiguation of these words has been an important issue in natural language processing. Feature selection and knowledge discovery based on the rules for word sense disambiguation are more important because they may provide some theoretical and the practical supports to natural language processing and linguistic studies. The approach of APOSD is proposed by Hong et al. In 2012 for classification and knowledge discovery. It is based on the theory of formal concept analysis, which describes the connection and the relevance between concepts in a strictly mathematical sense. And the visualization of the data structure is through concept lattice. However, there are some cross lines in the concept lattice, which brings some inconvenience in the reading of the diagram. This is the concept lattice of livings and water. As you can see, there are some cross lines in the diagram. Therefore, Hong et al. Proposed an approach of generation of attribute partial order structure diagram. It is based on the principle of partial order, which follows the basic principle of human beings' cognition of classification of natural things. That is, to put the objects with the common attributes close together, and to put the object with exclusive attribute away from each other in order to classify different things. As shown in the following figure, for the details of the approach, please see Hong et al. 2012. Here is the hierarchical relations of the objects and the attributes. And this is the procedure of the generation of the APOSD. And this is the formal context and the APOSD of livings and water. What we have done by the APOSD, first, we have done some study on word sense disambiguation of English modal verbs. And this research was published in 2016. Here shows the related works. And as you can see that the studies on word sense disambiguation of English preposition started from 2005 and during the time of 2005 and 2013. You can also see that in the previous study, the accuracies of word sense disambiguation of English preposition were relatively low. So in our research, we try to improve the accuracy of word sense disambiguation of English preposition. We take the preposition over as the target word, and we use the data from the SenseEval 2000 corpus. The two sense inventory are from TPP, the Preposition project, and from TRES in 2011. And this is the TPP sense inventory of over. And this is the sense categorization of preposition over. This is a scatter diagram of MI. MI means mutual information. We select the mutual information as attribute for word sense disambiguation. Here shows the MI between preposition and its complement noun. And this is the discretization of the MI. By the discretization, we got the range of MI value. And shows in this table. Based on this MI value feature or attribute, we built a formal context for the training set for the word sense disambiguation of over. And based on this formal context, we generate the APOSD for word sense disambiguation of over. And then we also used the sense inventory by TRES in 2011. And we also generated the APOSD for training set for over. Here comes the result of accuracy of word sense disambiguation by different approaches. As you can see from this table, APOSD reaches high accuracies of word sense disambiguation. In this research, the purpose of the research is to simplify the rules for word sense disambiguation. Since the APOSD approach is based on dataset structure, when the dataset is big, the generated APOSD will be big, and the rules for word sense disambiguation may contain many features, including some confusing features. In order to solve this problem, a filter is added to filter simple rules for word sense disambiguation. To some extent, avoid influence of confusing features. And then we also want to select optimal features for word sense disambiguation. The filter APOSD approach is a combination of a filter and an APOSD. Firstly, a filter is designed for filtering the simplest rules for word sense disambiguation. Secondly, an APOSD is used to extract complementary rules for word sense disambiguation and visualize the structure of the data sets. Thirdly, the rules for word sense disambiguation by the two approaches are connected, with the ones by the filter as the mainstay and the ones by the APOSD as a complement. And the features occurring in the final rules are selected. This is the framework of the filter APOSD approach. And this is the sense categorization of around in PTT. We choose the preposition around as a target word because in the previous study, the accuracy of word sense disambiguation of around was relatively low. And this extracted the features for word sense disambiguation. As you can see, both semantic features and the syntactic features were extracted. And here is the result of the word sense disambiguation. We make a comparison of the result with the previous studies. As we can see, filter and the APOSD approach reach the highest accuracy of word sense disambiguation. And all based on the rules of word sense disambiguation, we select the features and rank them based on their contribution to the accuracy of word sense disambiguation. We have also done the investigation of features causing semantic mergers of English modal verb made by APOSD. And this research has been published in 2022. What is semantic? Semantic merger is a case where context exclusive, that the two meanings are neutralized. For example, see the dialogue. A said, "Forever YH is a good bicycle." B said, "Well, it ought to be at that price." Here in this dialogue, the modal verb ought is in a case of a semantic merger between ought tentative assumption and ought weak obligation. It is not clear whether the speaker is referring to the maker's obligation to produce good bicycle, or he is making a logical assumption. It costs a lot, therefore it should be good. In this study, we choose the English modal word may as a target word. There's a semantic merger between may epistemic possibility and may root possibility. And as this diagram shows the semantic merger. Between may 1 and may 2, there's an area for semantic merger, may 3. So we categorize the sense of modal verb may as 3 classes: may 1, root possibility; may 2, epistemic possibility; and may 3, semantic merger. Firstly, the object of may is categorized into 3 classes: may 1, root possibility; may 2, epistemic possibility; and may 3, merger. Secondly, the roots for word-sense disambiguation of 3 classes are extracted. Thirdly, a comparison is made among the roots for different classes. Fourthly, the features causing semantic merger of may are discovered. This is the procedure of research. And this is the object distribution in the formal context. As you can see, for may 1, we use 50 objects, and then may 2, 50 objects. And for may 3 merger cases, we selected 60 objects. And also we extracted the features for the word-sense disambiguation. As you can see, we have semantic feature, syntactic feature, and situational contextual features. Based on the object and the features, based on this is the formal context of word-sense disambiguation of may. And this is a 5-fold cross-validation of the model. And then we extracted the rules for word-sense disambiguation for may class 1, may class 2, may class 3. Based on these rules for word-sense disambiguation, we build another formal context. And in this formal context, the objects are all the rules for word-sense disambiguation, and the attributes are the features included in the rules. Based on this formal context, we make analysis of the features causing semantic merger. This is the APOSD of the rules for may 1. As you can see, on the top layer, most of the features are the low MI value features. And this is the APOSD. Diagram. This is the APOSD features. And then we make a statistical analysis of MI value features. As you can see, for May 1, the rules for May 1, the low value MI features take the majority. And for May 3, high value MI features take the majority. And for May 2, syntactic feature take the majority. Here it comes to the conclusion. Most semantic features with high MI value are the features causing semantic merger between May 1 root possibility and May 2 epistemic possibility. 2. The syntactic features almost do not contribute to the semantic merger of May. 3. The situational contextual features representing topic related to result and the implied future time contribute to the semantic merger between May 1 root possibility and the May 2 epistemic possibility. That's all. Thank you for your attention.
So, any questions for her? Yeah, you can interact with her. I'm posting her email address. If you have any questions regarding the presentation, please contact her on this email address. Okay, thank you. We'll move to the next presentation.